located again on the mechanical levels. And part of the reason, again, why that can happen, some of the other strategies we'll run through very quickly. This building uses water to cool the building, not air. It has radiant systems. It has underfloor air. It uses about 1/5 of the amount of air to move around the building through the ventilating process. The equipment is much smaller, and again, the smaller equipment allows us to have these openings. We also look at, again, one of the other absorption strategies is collecting the energy from the sun. And there are many watts per square meter of energy that naturally fall on the skin of the building. These new tools, such as Ecotect, allow us to measure exactly how much energy we can expect to see on the skin of the building at all hours of the day, all year long, so that we can place photovoltaic cells on the building in those places that we know are going to give us the greatest benefit. So when you look, for example, at the very top of the building, the photovoltaics are located at the dome, an area where we have a very high level of solar radiation stress. And but you'll also notice that they were not placed on the top of the building in a symmetric way. And this was a little bit hard at first for our architects to understand why we would do such a thing. But again, the theme of the building is high performance, and to do that, to achieve optimum performance, you don't necessarily end up with a symmetric answer. The building also has a double wall, and this double wall is an active, ventilated, internally ventilated cavity. It becomes one of the strategies that we use to capture energies from surrounding the building. We use this cavity to heat air. We use the energy that is created by this hot air to draw it back into the building to assist in the HVAC design. This particular building will take this hot air from this cavity, we'll pull it in, and it will become the reheat source for our ventilation system. In Guangzhou, it's very hot and humid, so when you take all this hot, humid outside air and you bring it into the building and you wring all the moisture out of it, you cool it down enough to wring the moisture out of it, it becomes too cold to supply it to the building. So in typical systems like this, electric coils or gas fired heaters would be used to reheat that air to bring it up to a comfortable temperature. We use the sun's energy for